to solve a differential equation such as this one here, step by step, you just have to enter it under F1. And you have to enter the initial conditions, which are 0 and 2 for x and y, and just keep pressing enter. I'm sorry, F1 is where we enter it, F2 is where we go to solve it. That's why the menu is called solve. So we're going to select the first one, and we see that the general solution is this. And if we keep pressing enter, we will see that the solution is the fourth option here, this one. That is a correct solution. If you would like to see steps, you have to select F3, enter the differential equation just like we did before, and then you will see step-by-step solutions. Very well. Now, we would like to also solve this equation, this differential equation, numerically using the Euler method. So we go to F6. We go to F6, which is the Euler option. There we go. Enter the differential equation. 21 x squared minus 3 x squared times, very important to put the times symbol there. You cannot write x squared y, but x squared times y. Initial condition doesn't change. It's still 0 and 2. What we need to know is the step size, which is h, which is 1. And how many points? Well, to reach y of 1, starting at 0, it will only require one step. So we enter this. We start at 0, 2. We press enter to continue. And we get 1, 2. So our approximation for y of 1 is 2 if we use one step. But if we use a different step size, you can just go back here and select, instead of one step, let's say we have a step size of 0.5, 0.5, then it will take us 2 steps to get to 1. So we enter that, and we now have to press enter twice, because the first point is at 1/2, 0.5, and it's going to give us 2. And if we press enter again, we arrive at x equals 1 with a y approximation of 3.875. So the smaller the step size is, the more steps we have to take in order to reach our desired x value. And also, the numerical solutions are much more accurate the smaller the step size is. Thanks for watching.